The fourth type of addition reaction is an addition reaction with hydrogen halides. Hydrogen halides are, when we talk about hydrogen halides, we're talking about hydrogen fluoride. We're talking about the molecules formed when hydrogen and halogens react together. Group 7 elements are called halogens. So we're talking about the reactions of hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. And how are they going to react with alkenes? The reactions are exactly the same, and I'm going to give you an example of the reaction. We have again, I'm going to take the simplest alkene. We have ethene, and this ethene is going to react with, let's say, I'm going to make it react with HCl. So the product is, again, you're going to redraw the molecule of ethene, except for the fact that instead of the double bond, you're going to draw a single bond. So if you look carefully, this double bond is now converted to a single bond. So that's what you're going to do. And when you do that, this carbon atom is now no longer making 4 bonds, and this carbon atom is also short on 1 bond. It's making 3 bonds. So to complete the bonds, one of the hydrogen atoms is going to get added to one of the carbon atoms, and one of the Cl atom is going to get added to the other carbon atom. So this HCl molecule is going to split up into two. The H atom goes and bonds with one of the carbon atom, and the Cl atom goes and bonds with the other carbon atom. So you convert, in this reaction, what happens is you convert an alkene to a halogeno alkene, and in this particular case you're converting that into chloroethane. So it's a similar type of reaction, and in this particular type of reaction, the same rule applies, which we discussed earlier, which was that the rule was that the hydrogen atom is going to get attached to the carbon atom, which has more hydrogen atoms, So I'm going to do another example in which I'm going to show how this rule is going to fit in. That reaction would be of let's say 2-methyl-butene. So in that case, you have butene means that it has 4 carbon atom, 2-ene means that there's a double bond on the second and third carbon atoms, and 2-methyl means that there's a branch of carbon on the second carbon atom. And I need to complete the hydrogen atoms. So this is going to have 3 hydrogen atoms. This carbon atom is already complete. This needs 3 more bonds. So you have 3 hydrogen atom. This needs one bond, whereas this needs 3 more bonds. And I am reacting this molecule with let's take HBr now. So I'm reacting this molecule with HBr, and the reaction would be that in this particular case, I'm going to redraw the molecule, except that instead of the double bond, I'm going to have we're going to have a single bond. So let's redraw this particular molecule, and instead of the double bond, I have a single bond, and there's a carbon branch on the second carbon atom, and I'm going to draw all the hydrogen atoms now. This is going to get attached to 3 hydrogen atoms. There would be 3 hydrogen atoms over here as well. There would be 1 hydrogen atom over here, and there would be 3 hydrogen atoms on this side. Now, if you look carefully, these 2 carbon atoms where there was previously a double bond over there between the two carbon atoms, and now I've removed that double bond and replaced it with a single bond. So if you look carefully, those two carbon atoms have incomplete bonds. They are not making 4 bonds, they're making 3 bonds each. So what I'm going to do is I'm going to split up this HBr molecule, and one of the H atoms is going to get attached to one of the carbon atoms. Now this carbon atom is not bonded to any hydrogen atom, whereas this carbon atom over here is bonded to one hydrogen atom. So the hydrogen atom is going to get bonded to this carbon atom, and the Br atom is going to get attached to the other carbon atom. So remember, the hydrogen atom is going to get attached to the carbon atom which is already bonded to more hydrogen atoms. So this carbon atom is bonded to only one hydrogen atom, whereas this carbon atom is bonded to 3 carbon atoms, so it's not bonded to any hydrogen atom. So I'm going to attach this hydrogen to the carbon atom which is already bonded to hydrogen atoms. Now coming to the other details of this reaction, this reaction generally occurs at room temperature and pressure. So room temperature and pressure. The only difference is that when you have room temperature and pressure, the only problem is that that once if they're gases, if the alkene is a gas, and since most hydrogen halides are gases at room temperature, so they're going to mix together. You don't need to do anything. But if your alkene is a liquid at room temperature, then you would have to bubble it. You would have to bubble the hydrogen halides through that liquid. So the reaction is going to be carried out at room temperature and pressure, and the rate of reaction, the rate of reaction would be that HF is going to have the slowest reaction. Then the rate of reaction would increase. HCl is going to have a much faster reaction, followed by HBr and HI. So the speed of the reaction would be slowest for HF, and it would be fastest for HI.